Thanks a lot, everybody, for joining our today's session during the AskTOM office hours. It's a session that belongs to the Oracle Spatial Technology series, and I'm happy to be here today with two of my colleagues being the speakers for today. They are Giant and David, and they will be speaking about what's new in Oracle Spatial for the database version 23 AI. This is very exciting stuff, but before we talk about the new things, let me just recap one thing. Just in case you're new to the AskTOM office hours sessions, you will find the recording of this session and all the other sessions which we have already done in the past. They are published on the AskTOM platform. Just look for videos, which you can find here. Then search for the session, and there you will see the link to the recording. So much for the introduction. I think David and Giant, they will introduce themselves. I'm going to hand over to both of them. Let me just stop sharing. Giant,
Thanks,
David, the
Karen,
floor
is my
is
desktop.
yours.
So, yeah, I'll just kick it off here. Thank you, Karen. And I'm David Lapp. I'm a product manager on the spatial team, along with Karen. And we're also joined by Giant Sharma, who is our director of product management for actually both spatial and graph. And I'm going to start out with an overview of the new spatial features in 23 AI. Just give sort of a broad brush of the sort of the categories and what the highlights are, and then Giant is going to demonstrate a couple of the I think the most interesting and exciting aspects of these enhancements. So first of all, for any folks that are new to Oracle Spatial in general, just to sort of set the context for everything else we're going to talk about, our sort of motto and our sort of guiding principle with spatial in our team at Oracle is that everything happens somewhere. So spatial at Oracle is about taking location and location relationships and the ability to detect them and act upon them, and having that be just a mainstream capability along with all the other sorts of diverse converged capabilities of the Oracle database, every Oracle database. So we manage spatial data as a native data type and provide the ability to answer really all kinds of questions about locations and location relationships, and then operationalize that capability in the context of business applications. So, that's what spatial is all about, and what you're going to hear about today are some of the exciting new things that have been released in 23 AI. So a few of the sort of breaking this up into a few categories, and the first of those categories I think I'll just sort of describe as ease of use. So one of the aspects of Oracle Spatial, managing spatial data in Oracle database, that has historically been something that took a little bit of extra explanation, and we felt was a little bit of a barrier to entry, was the fact that when you're creating spatial data, and by spatial data I mean populating the native spatial data type in Oracle that stores points, lines, and polygons, which is SDO geometry. That's just the name of the data type. When you were populating or creating that data, there were some codes and identifying numbers in there that referenced other things that people, you couldn't just look at and easily understand, and weren't as intuitive as we would like. So we've done some work to ease that. And the first of the things that we've done is for probably the most common form of spatial data, which are just points in longitude, latitude data. And we've made it much easier to create those longitude, latitude points, and you'll see an example of it coming up. But the actual syntax for creating point geometries using longitude and latitude coordinates has become much simpler, and we've sort of removed a bunch of the encoding of things into IDs that took some understanding. The other thing that we've done for defining geometries that are not just points but lines and polygons is that in the place of these codes that would describe what type of geometry a particular item is, we've provided these human readable constants so that they can be used instead of these codes, just to make it more intuitive to get started. The next thing is that when you're using spatial data, generally speaking, you are going to create a spatial index for performance reasons. And the creation of that index, we've streamlined as well. And I'll demonstrate, or we'll take a look at what that means, but we've moved a step that sort of would historically slow folks down. Spatial Studio is our self-service tool that you have access to for free. It's one of the apps that you get with Oracle Spatial. And it's a self-service tool to work with data in Oracle. And we've done a whole bunch of things to make Spatial Studio also easier to use and allowed for improved integration and productivity. And a couple of those things include the ability to take the work you do in Spatial Studio and integrate it or embed it into other applications, as well as streamlining the ability to take non-spatial data, meaning data coming from spreadsheets and files, and with some reference to location and turning that into spatial data. We've made that easier. From the developer perspective, a few of the really important things are, first of all, one of the real cornerstone capabilities of Oracle Spatial is the ability to manage, process, and analyze raster data, meaning any sort of gridded data, whether this is satellite imagery or some sort of grid that represents land use or ground temperature or what have you. So that's a very mature, robust capability of Oracle Spatial, this capability to deal with raster data. It's called Oracle Spatial GeoRaster. Well, this big enhancement in 23 AI is that we have taken the whole GeoRaster platform and REST enabled it. So we now have a REST interface for all the capabilities of GeoRaster. Basically, anything you're doing with that platform is now sort of ready with a sort of a developer-friendly REST interface. The next thing that we've done, again, I think from the database developer perspective, is that specifically on Autonomous Database Serverless, we've added a SQL function for geocoding, address geocoding. So that means that the ability to go from street addresses and place names and convert those into geographic locations and geometries in the database no longer requires any additional component other than ADB serverless. Now, there's other tools and capabilities within the Oracle ecosystem to do that. For example, Spatial Studio that I just mentioned allows you to geocode, as do some other Oracle tools. But this basically means that if you have nothing but an autonomous database, that's all you need. You can geocode your data, and the geocoding is very robust, providing a lot of rich metadata feedback that tells you not only what the location of an address is, but all kinds of information about how well resolved the address was. Was it an absolute perfect match in a high confidence location, or was it a little bit ambiguous and there may be a little bit of an error bound around that location? All that kind of stuff. All you need is Autonomous Database Serverless to do that. And a bunch of other sort of similar developer-friendly aspects of Spatial Studio include an enhancement in the way that we work with web map services, a standards-based protocol for serving map data on the web. And so we've improved that in some other areas of integration of Spatial Studio with standards-based services to combine with your data in Spatial. And then finally, the last category here includes enhancements around 3D data, specifically point cloud data, which are just very large volumes of 3D points that constitute the results of typically LiDAR scanning. So when you're scanning a scene to create, for example, a digital twin of a particular site, or scanning the area surrounding railroad tracks or a road, looking at the overgrowth and creating just a 3D representation of surroundings of an area. that is another one of the spatial data forms that we have very robust support for in Oracle Spatial: point cloud data, 3D data, LiDAR data, digital twins. The enhancements around that in 23 AI include the ability to take a slice and develop a cross section, basically a planar representation of a slice through a point cloud or a 3D scene. Calculate the difference between 2 point clouds, and so that's effectively taking a LiDAR scan or having a full like 3D representation over time and detecting the difference by basically subtracting, the difference of one minus the other, so you can see what's changed across LiDAR profiles. And then finally, the ability to create a 3D mesh. So you could sort of think about that as taking a 3D point cloud and shrink wrapping it in 3 dimensions. That capability, that set of capabilities, was sort of highlighted at the last Cloud World event by our colleague Paul Parkinson, who had this great demo that showed 3D scans of a hand, first without and with a ring on, and the ability to do that change detection and identify the ring that's appeared. And so that's actually something you can look up on YouTube, and there's some really cool examples and demonstrations of all that capability. So that's the 3D stuff. And then finally, these are the last couple of things I'll mention, which are what we're going to highlight in demonstration, which are important enhancements for developers, specifically in the ability to consume spatial data in exactly the way that all modern web clients and toolkits want them, and that's in the form of vector tiles. So vector tiles are the industry standard format for sort of high performance delivery of spatial data to web mapping clients, and H3 is a indexing scheme for aggregating and summarizing very large volumes of point data through a hierarchical set of hexagonal shapes that summarize what's going on in those shapes. And we've added first-class support natively in the database for both of those key developer formats or structures, or paradigms, if you will, because this is what folks use and would typically be spinning up and leveraging additional tiers of software in order to support these things. And so now they're supported natively in the database. So let's just rewind and take a quick look in detail at a couple of things I talked about. The first one was around that more intuitive syntax. So previously, if you were going to be creating a point geometry in Oracle, you would have this SDO geometry data type, and then a whole bunch of codes and numbers and various things that would indicate that this is a 2-dimensional point, the fact that it's in longitude, latitude, the fact that it's a point array, all these things. That's all dissolved down now to what you see here on the left. It's just SDO geometry, longitude, latitude. The rest we infer and behind the scenes sort of do what needs to be done to formulate all the rest of the details. So that is the super simple constructor now for a longitude latitude geometry, whether you're inserting it as a point in the database like you see on the left, or whether you're using that, as you see on the right, as the query window for another query. Like if we want to find what's within a certain distance of a point, that point, which is now a query window, can be specified simply with that simple constructor. So much easier and kind of a slam dunk for being able to work with point geometries. The next thing for other types of geometries, like polygons, for example, when you're going to create a polygon, you would previously have created a geometry, an SDO geometry, and then put in the correct codes to indicate that it's a 2-dimensional polygon, that it's using longitude and latitude. Well, now you can see that in red, we have these global constants that can be used instead of those numbers. So you don't have to remember those numbers. You just use those constants, and you can use those both to create a constructor, to construct a line or polygon geometry. And you can also use them in a predicate if you wanted to detect which items within a table has a certain type of geometry. But again, this is meant to, I guess I'll say, demystify and simplify and allow people to more readily look at this and have it sort of make sense instead of saying, what are those first two cryptic numbers? Well, now you can use these constants. And then the other really helpful ease of use capability is in creating a spatial index. And it's not so much what we've done as an addition, it's really more what we've eliminated as an extra step. So in order to create a spatial index, there must be a row of spatial metadata that describes the geometry that's going to be indexed. And we have that to ensure consistency so that when a spatial index is created, that process first looks at some metadata to see what type of geometry, this should be. Should it be a two-dimensional point, a three-dimensional, line? What type of geometry is it so that the index can ensure consistency? Well, now what we've done and creating that metadata is something you can do with SQL, but it's a whole sort of a little bit of a nested structure that you have to understand. Well, what we've done now is that when there is data in the table, so if you have, and you would generally be, populating a table before creating an index on it, when there's data in that table, if you create a spatial index, we will introspect that table and we will create the required metadata automatically so that the create index statement can just run, and then we'll validate appropriately, and then all subsequent data that gets added to the table will comply. Will have to comply, and the metadata piece is just done automatically. So that's a real great ease of use, because now it's create table, add some data, create index, done without that extra metadata step. So I want to jump ahead now to focus on what we think is maybe the most exciting of these new features when it comes specifically to the developer community, because that's really who this next set of features are for. So vector tiles and H3. So as I mentioned before, vector tiles are just it's a format. It's a data format for delivering spatial data. It's a binary compressed format that encodes spatial data into encodes spatial data into tiles, and ships that spatial data along with attributes to a client that is that knows how to read that vector tile format. And every modern popular mapping client library toolkit, they all support vector tiles. So this is really the sort of the industry standard for shipping spatial data to a web client. And it sort of goes, I'd say, hand in hand with GeoJSON. So GeoJSON is also globally universally supported by these clients. And so for, I'd say, very small volumes of data, very modest volumes of data, that's perfectly fine. And the database has been able to support GeoJSON because of the great JSON support in the database. We've been able to do that for a while. We've had workshops on that and so forth. But when you get past that very small volume of data and really want to sort of scale things up and have a much more sort of fluid, responsive user experience, vector tiles are really the way to go. So having first-class support for that in the database is huge for the developer community. Some of the benefits of this are that, number one, what gets shipped in vector tiles is really the data, the attributes, the geometries, and the styling of that data is done using style sheets, basically. And so that can be invoked by the client. One set of vector tile data can be dynamically styled in a whole bunch of different ways. So vector tiles are very popular for both sort of data layers that you're going to put on top of a map. They're also very popular for using as base maps themselves. And part of the beauty, especially when you're using them as base maps, is that you can have one vector tile data set and apply a bunch of different styles to it to have different looks and feels for your data, instead of having to have, for example, with an image tile-based map, physically building a separate set of tiles for every look and feel you want. Same thing with the way that you can have one set of vector tiles for some data, and they can be dynamically styled in different ways by different clients. It's also very fast, very smooth, and as I said before, it's supported across the industry, which is really why we've done it. It's sort of guaranteed to be something that anyone in your organization that's integrating maps into applications will know how to read this vector tile format. What does it look like? Well, it's a SQL function. It's a new function in our SDO util, sort of a utility package, and it is pretty straightforward. So you specify, to get a vector tile, you specify the name of the table and the geometry column in that table, and then the tile parameters themselves. So specify the specific tile you want. So it's the zoom, the X, and the Y, and those are all sort of standard aspects of requesting a vector tile. And then you can specify the attributes that you want to be shipped along with the geometry. So you can use those for pop-ups and tool tips and styling and so forth. So this alone, when I say that this is really a developer resource, folks aren't going to be just running the SQL function, getting back a vector tile and doing something with it. The point of vector tiles is really to stream spatial data fluidly to applications, whether like web and mobile applications that are just streaming spatial data to maps based on how users are moving around and searching for things and querying and filtering and so on and so forth. So this is what the sort of the foundational function is for getting a vector tile operationally, and sort of in terms of the real use case. What is done is that some sort of API is generally developed that allows a client, a developer, to dynamically request the vector tiles they need based on whatever sort of user interactions are going on. So it turns out that because of the fact that Oracle Spatial is part of Oracle, and Oracle is this converged database with all kinds of useful developer features, we're very much involved in working together with them. And one of the chief among them that we work with all the time is Oracle REST Data Services, ORDS, which is the exact thing that we need to complete this solution. So what ORDS, Oracle REST Data Services, is all about is taking anything you have or anything you do in the database and REST enabling it. And that's exactly what we want to do here. We want to take that function, that get vector tile function, and we want to wrap it as a REST endpoint that will fluidly accept the zoom X and Y parameters as a user is cruising around in a web application, and return the vector tile vector tiles based on the current viewport of the web application. And that's exactly what we do, and that's something that Giant will demonstrate, and works tremendously well. So that's vector tiles.
So
Now,
David, hopefully those weren't famous last words. You're invoking the demo gods at this point.
Yeah, well, I guarantee it'll all work perfectly without a hitch. Right? I'm very cavalier with that, since you're going to demo and not me. So no, it does. ORDS is really rock solid for this kind of stuff, and we are always, when we're building this kind of stuff, we're doing it sort of knowing that these are going to be resources that are going to be wrapped with REST. And so the next example of that same theme is H3. So as I mentioned before, H3 is this hierarchical index of hexagons, and hence the H, that cover the globe and are meant to represent a summary of what's going on inside each little hexagon. And so the idea is that as you zoom in and zoom out at different scales, you configure sort of the level of these hexagons that are appropriate for any given zoom level. For example, as you zoom in and out, you may always want to have a consistent size hexagon on the screen. So that would sort of dictate what level of this hierarchy of hexagons you want to display at any point as you're zooming in and out. So it's this global hierarchy of nested hexagons. And so they allow you to take very large volumes of point data and summarize those points within these hexagons and zoom in and out and cruise around and be able to sort of see what's going on in a broad sense. And as you zoom in, you explode these hexagons into smaller hexagons. And so in order to accomplish this, what is done is that the original point data is processed. There's an initial process that generates this H3 index of data, and that is what ends up being rendered like you see over on the right. So what it looks like is the following. You start with some data, you start with some point data, and it looks like we've got this county H3 table, but presumably this would actually be a table of points and not polygons. But you'd start with a table with points. You would process that table with this H3 sum, which stands for summary, H3 summary create table. You process this table where you're specifying that the table that's going to be created as an output, this H3 output result, the table you're processing, the geometry column, and what type of aggregation do you want? Do you want to count the items inside each hexagon, or do you want the minimum value of each item in the hexagon? What type of aggregation you want? In this case, we want to count them. So when you do that, the result is a table. The result is whatever table you specified as the first parameter, and it's the one that ends in the underscore H3. And that resulting table is the H3 index. And we'll be able to, Jai and I can open up an example of that to show when we're showing things. But once you have that table, then that is your H3. That table is not automatically tied to the original table. It is now a derivative product. You now have an H3 index, which basically contains the information about every hexagon at every level throughout the hierarchy globally that has any point or more than one point in it. And so just like with vector tiles, you generally wouldn't just be making that vector tile query and getting back a vector tile as an end user and doing anything with it. It's all about that REST API and getting vector tiles and integrating it in an application. Well, it's the same thing here. You generally are not just going to get an H3 hexagon as an ad hoc query. Generally, what you want to do is you want to take that H3 index and stream it as vector tiles to a client exactly the way you did with whatever data you were using the get vector tile function with. The only difference here is that instead of streaming spatial data from a geometry column using that get vector tile function, now our source is this H3 table, and we want to stream those hexagons as vector tiles. And that's what this function we're looking at here does, H3 sum vector tile. Because as opposed to streaming just some geometries in the database as vector tiles, here we have these encoded hierarchical hexagons that need some extra treatment to be able to sort of unpack them and stream them as vector tiles. That's what this function does, and that's what we'll sort of show what that looks like to have a web client that will, of course, this gets wrapped with REST API with Oracle REST Data Services, just like the other function did. And then a web client can just make REST requests and get those hexagons. So I think that's the sort of the overview of things. Giant, if you want to show the H3 or the get vector tile stuff, that's fine. If you want me to show H3 stuff, I'm ready to turn over to you or take your lead.
I'll start, and then if all your angering of the gods results in chaos, you can then
yeah, it's guaranteed to crash right now. I can tell you. I sabotaged it.
So the deal is I'll share and I'll show the demo, but feel free to add commentary as we go along. Okay.
Yep.
And Hopefully this shares multiple screens. Just tell me. Does it share multiple screens?
Yeah, well, we can see the different tabs as you move around.
Yeah,
Okay, good.
exactly.
Just seeing your browser
That
now.
was the whole point. Oh, I logged out of my cloud instance, but hopefully this is still alive. Just give me a second. Oh,
Yeah.
yes, it is. Okay. All right, we'll start with the vector tile. So this is like, I don't know how much data, but a few 100,000, I guess, or so of incidents. And I'm just going to do a reload. And essentially you can see the tiles being generated and being brought back, right? And you can have some property along with it, in this case, the severity of the incident. So that's the vector tile. I guess you can zoom in, zoom out, it'll fetch new tiles as we do that. Move around, maybe zoom out, right, to get more tiles. So that's the vector tile. And then we'll show you how this is done. And same thing with H3 aggregation. So all we are doing is aggregating the number of incidents within a hexagon, right? Zoom out, zoom in, same idea. All right, so David, do you want to walk through the details of this, or I can bumble through it either way?
I just suggest showing the query.
Okay. So you're not going to explain, what's a module and what's a... we just go straight to the handler. All right, we go to the handler, show the query, and then work our way back up. All right?
Yeah, exactly.
Okay. So let's actually start in that case with vector tiles. All right. So with the vector tile, right, I've simply got there's no geometry column. We just have a function which, given a longitude, latitude, or a x and a y, returns a geometry. We say what is the attribute that we want along with the points in the tile. In this case, the severity. That's what we're using over here for showing, right, on the pop-up. And the table is incidents. This gets the geometry that says what's the attribute. And then what's going to be passed in from the client is this, right? The zoom level, the X for the tile and the Y for the tile. The tile in this case, we're just assuming the default tiling scheme, which in this case is Google. You can choose to use the TMS, so the OGC TMS tile matrix set, which is a little more complicated, but I just took the Google default one. So you get the X, the Y that it's going to pass in at the end, and I will show that when I do when I show the source, but it passes in a y.pbf. So we want to strip out that pbf part so that we just get the number, right? And then the zoom level. And that's it. And then the client needs to know that it's getting back the data as in the Mapbox vector tile format, which means in the protobuf format. So it knows what it's looking at. All right. So that was the case
Giant,
for...
can I comment quickly?
Yeah. Go ahead. Exactly.
Yep. So, for context, so Giant is like kind of deep within that Oracle REST Data Services area where we're REST enabling the result of get vector tile. And so what you see on the top, that select application / et cetera, is just a header that comes back with the REST request. That's not part of get vector tile or anything. It's just something a header that's required. Really what this is meant, if you just look at the second line, SDO util get vector tile, and that's basically what we want to demonstrate just at the SQL level to start. And then we'll sort of back out and show how this is actually sitting, that this query is sitting in the area that allows that to be REST enabled. And the :X, :Z, :Y, those are the placeholders that would come in a REST request. And so, John, you could like just run this, run the query and just show that you get back a blob, and you're going to supply the, I think because you highlighted Mapbox, it may be only running that one word.
Oh,
Yeah. Just don't highlight anything and run the whole command. Yeah, you're still highlighting dual. Maybe that's why.
so much for that. Highlight the whole thing, see what happens.
And then we know that 464 is fine, so that would specify the, the tile XY and the zoom level. And then this is just going to run that query. And of course, like the first field is just that text string that's part of the header, that media type thing. But what's important there is that blob. That blob is a vector tile that we kind of manually supplied values for to mimic what would happen when a web application is just users moving around and the web application is just constantly making these requests. So John, I just wanted to like insert that.
Okay, so let's look at the source. Right, so the key part is here, right? This is the request that's going to be sent. And these are the parameters, the zoom, the X, and the Y. And it's going to be sent right from the client. In this case, we're using MapLibre. And anything else you want to add, David?
No, well, you could show the on-click, event, and the fact that you're getting the severity is what you had specified to be.
That's this part, the on-click event here.
So when Giant specified which column to include, that means it's then available for a click event to retrieve. And the unpacking of that vector tile and giving you the ability to have an on-click event for a tooltip or a pop-up and all that stuff, that's all what you get for using a format like vector tiles that these clients just know how to work with. So we didn't have to, so like this client, MapLibre in this case, just knows how to work with this vector tile format. All we had to give it was an endpoint to get the vector tiles, and then just work with the API in this case, opening up a info.
And then and then the styling is done on the client. You could just pass in a CSS, or you can style it manually, programmatically. It's for each individual layer if you want, but yeah, that's up to you. Actually, I should create an example which uses CSS instead of this process, but
David, Giant, Martin raised a question. We probably need some more information or a better explanation of what you are looking for, Martin. So maybe you can just unmute yourself and ask the question now, because I think it fits right now into what Giant and David
I can see the question
shown.
so
I'm not 100% sure about
I'm looking at the question right now. If you have open layers and you zoom in, the query is sent with another window. Maybe we need a little clarification on. Does this have to do with data that's being changed?
Martin, do you want to unmute yourself? Okay, maybe we can pick it up later.
Yeah, we'll definitely, Martin, we'll be glad to follow up if they understand. But I think in general, he's looking for the unmute button. But I can tell you that the unlike the H3 that we saw, where you're creating H3, you're creating a new separate table that you're then rendering with Get Vector Tile. You're converting your baseline data on the fly at runtime to vector tiles, unless you choose to pre-cache or do something different. But if you're using this function, you're going to see dynamically the state of your underlying data, if that's sort of part of what's being asked. If in one window you're using some tool that's making changes or doing things, and in another window you're streaming vector tiles, will you see that real,
Yeah, let's just go through that in detail, and I'll give my assumptions as I go along. And then, Martin, I will just give me a second. Unmute you so that you can. Martin, allowed to talk. At this point, you should be able to unmute yourself.
Can you hear me?
All right. So
we can hear you.
Let me just. So the point you're saying is one session has got the client application, right? Open layers, map-libly, whatever it may be. Another session, another application is updating the base data, the base table for incidents, and you're making those updates, right?
Yes.
And when you zoom in, if the zoom in query happens to happen after the other session has committed, not just updated, not just inserted, but committed,
Yes.
then yes, you will get the latest data. If they don't, you won't get the latest data. Second thing is, if you do things like use something else in between, right? A cache, for example, like true cache, again, you're not going to get the latest data. And that's essentially it. If those sessions, depending on when the query is made, they're going to get data that's maybe a little stale, depending on, right.
So you have to take into account, if you're using a cache,
Yeah.
then you have to refresh that cache.
Yes.
Okay, that was
And
also
I mean, you can certainly set up true cache and it will refresh, but then there are some complications over here on true cache will refresh based on what it knows which rows are done, but here it's a set of rows that are being aggregated. So I'll do some experimentation and tell you the impact of that. But basically what's going to happen is the cache will refresh, but it's not going to refresh as quickly as if you were to read it from the database directly.
Okay. And in another scenario, if you, for example, once a day would create all the tiles, can you store them?
Yes, you can.
So that would mean probably that the application would be even faster.
Yeah,
As
can
that
store
you
them.
are going to
But that's the
stream.
whole point of using something like true cache, right? It'll keep caching it and it'll save you a lot of headache in managing caches. And I just have to understand. I mean, it'll work really well if you were working directly against the table. And but I'm going to run some experiments to see what's the lag in this case. But that's the whole point of having something like true cache built in with the database, which then simplifies your whole cache management and cache consistency problem.
Okay,
Yeah, as
thanks.
long as the data is quite static, then there may be a point in storing the tiles and then reusing the stored tiles. But if the data is kind of dynamic, yeah, it might be better to do the get vector tiles directly to fetch the actual data.
But the
Yes.
bottom line is, yes, you have to understand, if you use a cache to speed things up, what's the relationship in terms of cache consistency and how to keep the cache consistent with the base data.
Okay, thanks.
I think, David, that was it. The H3 is essentially the same thing, different query. So that's why I stopped sharing. But
All right. I can show the H3 if
yeah, go ahead.
we have time. And it's going to be really, like you said, John, it's variation on
have the time.
Sorry, Karen?
We do have the time, so
Okay,
it's
cool.
probably interesting to show it.
Yep. So yeah, I'm now in the same. Karen, can you see my screen?
Yep.
All
Perfect.
right. And am I sharing the right screen? You see the rest? Am I sharing the screen with database actions rest?
With the
Okay, cool.
database actions, vector tiles.
Yep. So we're sort of in the same area that Giant was in, and so this is where we would take these queries and REST enable them. So I've got an API here for H3, and this is just an example of a query that just like the get vector tile that took the Z, the X, and the Y dynamically from a client, this is going to do the same thing with H3. And you'll see here that I have, so with H3 summary get vector tile, that's assuming that you've already created your H3 table. So remember, the first thing was like the function that creates the table to begin with. So I've already run that on a point data set, and I've created this EPA, TRI, et cetera, H3 table. So it's a bunch of facility locations, and so I've run that SQL command. I've got my H3 table. Now I want to be able to invoke it and get vector tiles of those hexagons from a client, just like Giant showed with just the straight get vector tile from spatial data. So I have the same header, which is just unrelated to our function, but it's just so that the client understands the format that's coming back. So I'm going to run the H3 sum get vector tile, specify my H3 table, and then for level number, this is the sort of the vertical level of that hierarchy, which sort of means bigger hexagons or smaller hexagons. And instead of just specifying one level so that wherever I am zooming in, zooming out, I'd always have the same sort of size hexagons on the ground. I've just done a very simple case statement that will give me different levels of hexagons depending on my zoom level. So this is just my own kind of shortcut. And one of the things that we're doing, planning as an enhancement, is to sort of automate some of this with some defaults to make it easier to automatically have the function know how big or small the hexagon should be at any level. You can always override it. You can always do something like I'm doing here, but I'm specifying that that the level of the hexagon hierarchy that you get back is sort of based on the zoom level that you're in the client. And then I'm going to specify the X value and then the Y value and handle that PBF suffix, which is the standard suffix name for a vector tile itself. So anyway, that's what I'm going to do. And if I run this function, and I'm going to have to supply values because I put placeholders in. So I'll supply a tile XY and a zoom level. And when I run that, just like we did with the vector tile function, I'm just getting back a blob because those are just vector tiles. So in order to work with this, I mean, up here, you can see that I've highlighted, this is what the API, what the REST endpoint looks like. And then here's a client that is, again, the same client that Giant was showing, the MapLibre JavaScript library, consuming that endpoint. And here I'm just showing the number of items because the aggregation I did in this H3 index, the aggregation was just to count how many items are in each hexagon. So I'm color coding these hexagons, which are just coming back as vector tiles from that function. And then this thing that I did here that specifies which level of hexagons should I get back as a function of the zoom level in the app, because that's one of the parameters that's in the REST request is Z. I know what the zoom level is in the client, so I'm specifying how big the hexagon should be as you zoom around. So now as I zoom in, the hexagons are automatically going to scale and get sort of smaller hexagons as I zoom in, smaller on the ground, so that I maintain a somewhat of a consistent sort of coverage of how many hexagons I'm seeing. Now, I did this with that case statement, a very, very like brute force, simple way to go. But there are more elegant ways to do it. And Giant, I know, has some much more clever ways to do it. And as I said, we're also adding some default behavior so that if you don't do anything, there'll be sort of a default behavior in terms of giving you consistent sizes. But obviously you can see here that as I zoom way out, we're aggregating more and more. And then as I zoom in and explode these guys out, we're going to be seeing, fewer items because we're going to be exploding every one of these hexagons out into into what's going on inside each of them. So, that's basically it. Then if we take a look at, what's going on with the requests behind the scenes, take a look at the network. And as I zoom out, all of a sudden we're going to see these REST requests. And so here we have an example of one. And so you can see what I've got highlighted here. The MapLibre client automatically structured this request for zoom level 2, tile 2, X2, Y1, PBF. And so that's requesting a vector tile. And where that's coming from is exactly the same sort of thing that Giant showed. So this is where the request is being made by the client. The client knows how to work with this PBF vector tile format. And then I can do my own, have a layer. I can style it. I'm here like Giant did. I'm styling it in a crude way, just in the JavaScript, but this could be a separate style sheet. I have an on-click function that is giving me, I'm just setting, using HTML, but I'm pulling out that count property out of the vector tile that the client knew how to work with. And if we actually look here at, I'm going to go over to SQL for a moment. And if we look at what's actually in the data, here we have the original table. And that original table is just a bunch of points, some ID, coordinate, and a geometry. And I ran the command that creates the H3 index. And here's the H3 index itself. And we take a look at this data, we'll see the following. It has the H3 index. Every H3 index you create, they're all going to look like this. The only thing that will vary will be what the column is that you create as the aggregate value, because that's one of the parameters when you're creating the H3 table is what do you want to aggregate and what should the column name be for that aggregation? And I just say CNT for count. But the first column is the level number. This key, this is like the actual blob content of the index of that H3 hexagon. So this is a key that for a given like ZXY, this key specifies a hexagon. And we have the level numbers. And so this is the content. This is the table that function that we saw, the H3 vector tile function. This is what that function is operating against. And that's why we need this separate function to return H3 hexagons as vector tiles as a different function than the one that's just get vector tile from geometries, because that's for creating vector tiles from just SDO geometry data in a table. This H3 get vector tile function is specifically for understanding and unpacking this structure and giving you back a set of hexagons at a given zoom X and Y and rendering this. So I think that's the, pretty much what we have. I don't know if, Karen, are there any other unanswered questions at this point? Otherwise, I will.
Not that I see.
Okay.
No.
So let me
no
conclude.
questions.
Yeah, so I just wanted to share here some resources that folks can check out, including some more info about the things we just talked about, but also some hands-on workshops and other social network sort of stuff. So definitely take a look at these resources. And I think we also want to put in a pitch for a really, really interesting upcoming session that's going to be done by our partners from ITIS Corporation. Jerry and Christy are going to talk about their traffic safety solution, which is built upon Oracle Spatial and Oracle Apex and really sort of using a lot of advanced capability and functionality and doing some really, really cool stuff. And they incorporate machine learning and so forth. Giant, you're going to say something?
Yeah, over and above that, the reason it's relevant to this is that they use vector tiles and H3 aggregations.
Yes.
That's what they'll demo.
Yeah, it's a great way to take the things that we talked about today as conceptual things and really see like a real world important use case for them. And that's not that's going to be a webinar that's part of the series by the Analytics and Data Oracle user community, which is a user-driven.
Oh, yeah, I should explain that part too. All right.
Yeah.
Because the next one is exactly the same thing. And so they will do a high-level business overview, what problem does this solve for the end user from a business perspective? That's going to be the Analytics and Data Summit on the 20th of June. And then if you go to the next slide, the technical, here's how we built it is going to be an AskTOM office hour.
Oh, cool. All right.
Okay. That's good to know because I have the same slide in my deck, so I actually had the information.
Yeah, so this is going to get into
to
the nitty gritties, here's the code, here's how it was done, etc.
Okay. There's still one more question, maybe Giant, if you could have a look at, and then I can take over the presentation from David to check whether there is something else we are missing.
Right. Yeah, I have to go back and look at the OGC API. The extent of the compatibility is that we support the TMS option also. I have to look at whether the OGC API lets you define your own tiling scheme or not, because over here the tiling scheme is fixed, which means the number of levels, the extent, etc. And the difference between the Google scheme and the TMS scheme is simply saying within a tile how the offsets are computed, bottom left, top left, etc. But they both support the same, the way in which the tile is encoded is the same. The difference in OGC is you can use it for any tiling scheme in any extent. So there must be a way for you to specify what the scheme is in order to understand what the tile matrix set actually means when you say ZXY. What do they mean? So I will get back to you on that, Martin.
Okay, thanks a lot. So we have already seen the two advertisements for the sessions of our partner ITIS, and the next AskTOM session is planned for June 25, and we will be talking about spatial enhancement in Oracle machine learning. Now, okay, so this is what we've seen. Exactly this one. We've taken care of our questions, provided some answers, and you've seen that David has already shared the most important links. If there's nothing else you want to ask, then thank you very much for joining our session. And if you have any questions,
not hope to see you next year, but next month again for the next.
Oh, yeah. Okay. That's true. Next time. So next time is next month. Perfect. Thanks a lot. It's next fiscal year for us. Maybe this was what came up to my mind.
Oh yeah, that's true. That's true. That is true. Yeah.
Yeah. Okay. Okay. Perfect. So just in case you have any open questions, feel free to reach out to us via email. So the email pattern is very simple. First name dot last name at oracle.com. So any open thing you want to clarify with us, feel free to send us a message. Thanks a lot again, and enjoy the summer, and see you hopefully next month.